In this video, we're going to summarize those postulates and theorems that we learned in chapter 3. So the first thing we're going to look at is a couple postulates from lesson 3.1, which told you, first of all, in postulate 13, if you have a line and some point not on that line, then there is exactly one line through that point that is parallel to that first line. Postulate 14 tells us that if you have a line, and again some point not on that line, then there's exactly one line through that point perpendicular to that first line. Okay, and then the next few postulates get into parallel lines with transversals. Postulate 15 told you that if you have two parallel lines cut by a transversal, then we know that those corresponding angles are congruent. For example, this angle would correspond to this angle, and those would both be the same measure of degrees. All right, postulate 16 is actually the converse to postulate 15. So now it's saying if you have two lines cut by a transversal in such a way that the corresponding angles are congruent, then you're going to know that those two lines cut by that transversal are in fact parallel. So you can see that 15 and 16 are just a converse of each other. In Theorem 3.1, that again starts with if you have two lines that are parallel and they're cut by a transversal, then we know something about the alternate interior angles. And it turns out that those alternate interiors, for example, these two obtuse angles, are congruent. Theorem 3.2, again, starts with two parallel lines cut by a transversal. And if that's true, then we know something about the alternate exterior angles. And it turns out that those alternate exteriors, for example, these two, are congruent. Okay, in Theorem 3.3, we start again. If you have two parallel lines, and those are cut by a transversal, then in this case, we're going to look at the consecutive interior angles. For example, if I call this here angle 1 and this here angle 2, now those are not congruent in most cases, but they do add up to equal 180 degrees. So they're supplementary. Now the next three theorems are going to be the converse of Theorem 3.1, 3.2, and 3.3. In Theorem 3.4, that tells you if you have two lines cut by a transversal in such a way that it creates congruent alternate interior angles, then you can say that the lines are parallel. So those two horizontal lines in this case would be parallel to each other. So if you see, Theorem 3.4 is actually the converse of Theorem 3.1. And the same holds true for Theorems 3.5 and 6. So let's take a look. In Theorem 3.5, you have if you have two lines cut by a transversal, in such a way that the alternate exteriors are congruent, then you can say that those two lines are in fact parallel. All right, moving on, Theorem 3.6 is the converse of Theorem 3.3. So it says if you have two lines cut by a transversal such that the consecutive interiors are supplementary, then you can say that those two lines are parallel. All right, the last few are going to stray away from transversals a little bit for a while here. So Theorem 3.7 tells you that suppose we have these two lines, I'm going to call them A and B. If you know A is parallel to B, and you know that same line B is parallel to another line C, so B is parallel to C, then this is that transitive property of parallel lines. You can conclude that the first line, line A, is parallel to that last line C. So A is parallel to C. Theorem 3.8 deals with a linear pair of congruent angles. So if you have two lines that intersect to form a linear pair of congruent angles, so if these two here are congruent, then you know those two lines are actually perpendicular to each other. So that would turn out that those are perpendicular. All right, Theorem 3.9 deals with some more right angles. So if two lines are perpendicular, so there we have two lines that are perpendicular, then those two lines create four right angles. Theorem 3.10 tells you that if you have two adjacent angles such that this side and this side are perpendicular, then we can say this. So those two angles, let's call them 1 and 2, are actually complementary. So that tells us that the measure of angle 1 plus the measure of angle 2 is 90 degrees. And then in the last two examples, we move back to transversals. So if you have two parallel lines cut by a transversal, and that is perpendicular to the first line, then we know that line is also perpendicular to the other line. Okay, that's if you know the two lines are parallel. Theorem 3.12 goes along those same lines, but now it's saying if you have two lines cut by a transversal, and that transversal is perpendicular to both of those two lines, then we can say that those two lines it cuts through are parallel. So now we know that line and that line are parallel. So remember, you can use these drawings on your test, and good luck.